Alright, this is section 6-2 on proportional and non-proportional relationships. And basically we can know the difference between these pretty simply. Proportional relationships go in a continued pattern. So if you take a look at this pattern here, 3/1 to 6/2 to 9/3. This is just one example. 12/4, 15/5. That is a proportional relationship. And the reason is basically all those fractions are equivalent. They are all equal. They're all equal to the number 3 if you divide it. But also one thing you can notice is these all go up the same amount. And this is up or down, that's plus or minus. Up 3, these all add 3 each time. And then on the bottom, these all go up 1. So on top they have a pattern, on bottom they have a pattern, but the pattern is adding or subtracting. If they have a pattern of multiply or divide, that would not be proportional. So that makes it a little bit different too. But those are all equal, so those therefore are called proportional. And an example of non-proportional would be like this. 4/1, 6/2, 8/3, 10/4, 12/5. Now you can tell each of these go up a certain amount. These are going up 2 each time, and the bottom ones are going up 1. But in this case it doesn't matter because these are not proportional. 4/1 is not the same as 6/2. That's not equal to 8/3, it's not equal to 10/4, and it's not equal to 12/5. So before you start this section, this is a really important concept to know. Those on the bottom are not equal, so they are not proportional, and the ones on top are equal, so they are proportional. So here's example number 1. Example 1 looks like letter A. Determine whether the set of numbers in each table are proportional. So in the example here, you can look at the table and say the coffee for pounds is, if it's 1 pound it costs $3. 2 pounds cost $6, 3 pounds cost $9, and 4 pounds cost $12. So is that proportional or not? Basically what you can do here is make fractions out of all these. Is 1/3 equal to 2/6? Yes, those are the same. Is that equal to 3/9? Yes. Is that equal to 4/12? Yes. So since they are all yes, then this is considered a proportional relationship. Let's look at example 2A. So in this example you have the table of time in hours versus distance in miles. Time being 1 hour, 2 hours, 3 hours, 4 hours, and the distance. So in 1 hour you travel 50 miles, 2 hours is 70 miles, 3 for 90, and 4 for 110. So you're determining is this proportional? So in other words, just make these fractions. Is 1/50 equal to 2/70? Well, 2/70 if you simplified would be 1/35. 3/90 simplified would be 1/30. 4/110 would be 2/55. So as you can tell, if you simplified these, they're not the same fraction, so they are not equal. So therefore this would be called non-proportional. Or you would just say no. So that is example 1. And that was 1B, not 2A. So here we have what's called the constant of proportionality. That is a an extremely important concept for 7th grade math. It's something that will, for certain, be on your PARCC test at the end of the year. And that same phrase, constant of proportionality. And the constant of proportionality in this equation here is the letter K. But it's not really a difficult concept. All they're saying is if you have a proportional relationship, so it has to be a relationship that's proportional, and you can see some of the tables, whether they are or aren't. The constant of proportionality is the number by which you are multiplying by that continues the pattern. That's kind of a generic way to explain it, but that's basically what that is. So here in example 2, it talks about the circumference of a circle with a diameter of 4 meters. It says is about 12.56 meters. A circle's circumference is proportional to its diameter. Write an equation relating the circumference of a circle to its diameter. What would be the circumference of a circle with a 6-inch diameter? So basically, you have a formula here in circumference is C equals pi d, or diameter times pi. In this case, the constant, in other words, the thing that remains the same, it is constant, is always pi. So the constant of proportionality in circumference is approximately 3.14. So in this case, K stands for constant of proportionality, is 3.14. But this question also wants you to find the circumference if the diameter is 6. So all you're going to do is take 6 and times it by the constant of proportionality. So let's go ahead and multiply those. So circumference, as you can see, is about 18.84. This would be meters. So that is a constant of proportionality for this section 6-2. Good luck.